Kinematics, lesson number 19. Under that, projectile motion. Today, we'll consider another type of a projectile. You stand at a height. That means maybe you are in one of the apartments of a tall building, a skyscraper, and just throw some object from there. This height is supposed to be known. From here, throw a ball. You can throw it in many ways. You can throw it like that. You can throw it like this. You can throw it simply horizontal like this. So these three cases become three kinds of projectiles. So to begin with, we'll think of a case like this. We are projecting this width V0 like this. That is horizontally. What do you mean by horizontally there? Parallel to the ground. So H is known. V0 is given. So these two things are known to us. Okay. Now you will know that the body goes in another parabolic path. Not exactly the same parabola we discussed in the previous example, but this is also a parabola. Remember, like I told you, when you project like this, don't make it go like that. One simple trick is that the velocity must be horizontal to the path, sorry, tangential to the path. So that will happen when this path lies like this, isn't it? Like this.
Yes,
That velocity is tangential. Okay. So the body after some time will fall here. Once again, ignore air resistance. Ignore air resistance. Remember, considering air resistance is very practical, more useful in our day-to-day applications. But in physics, we need to start with the simplest of the thing. We need to approximate. Though you cannot get a situation where there's no air, think of what will happen if there's no air, and then you can see what happens if air is there. So you should never get into a wrong impression that how can you ignore air? Approximation and superposition is one important scientific method to understand complicated things. You know what are the words I used? Approximation and superposition. What does it mean? Like on a system, there will be many factors affecting its nature. Factor 1, factor 2, factor 3, factor 4. I'm not talking of forces. Some factor is affecting the system. Many factors. You would like to know the combined effect of all these factors in the system. To do that, you will approximate first that F1, factor 1 is only acting, others are not acting, you think. That's approximation. And see the effect of this factor on the system. Similarly, you think of factor F2 alone affecting the system without these things doing nothing. Like that, you approximate every time that only one is acting, the others are not there. And once you know the effect of individual factors on the system, you can superpose them to get the net effect. I always keep giving an example. There's a person who is an alcoholic, who drinks, who smokes, who does many bad things like this. So what is the effect of all these bad habits on him? When you would like to test, think of what alcoholism will do. Probably that will spoil, for example, the liver. and the smoking might spoil the lungs, and something else might spoil the kidneys. So individually you can think, and then if the fellow is having all the habits, the whole organism fails because every organ inside the body is affected. So whenever we say some approximations like this, never should you think that this is not right, because you cannot ignore air resistance. You can ignore air resistance, at least in the theory, and calculate what will happen without air, and then easily you can calculate what will happen with air. Hope you understood. I've given you so much information about that approximation and superposition. Now G is constant as usual. G will be acting down everywhere, isn't it? G is down. Now as usual, first, velocity is a function of time. Velocity as a function of time. What do you mean by that? After the body travels some distance like this, what will be the velocity here? Remember it, anytime the velocity will be in terms of direction tangential to the path. This I've been talking many times. The instantaneous velocity is tangent to the path, along the tangent to the path. So this is the velocity after a time t. This is v. This once again is supposed to be having two components. One x component like this, the other y component like this. This is Vx, this is Vy, this angle may be some theta, for example. Vx will be V only, V not only. Whatever velocity you've given here doesn't change because gravity is acting only downwards. This component of velocity is not going to be affected by the vertical acceleration here. So what you need to know is V0 remains unchanged. Remains unchanged. But since gravity is pulling the body down, the body keeps gaining the velocity in the downward direction. Remember here, initially, in the y direction, initial velocity is 0. All the velocity was given only in x direction. For example, if I took x and y like this. Initial velocity in y direction is 0 because we provided the body this kind of a velocity. Hope people are understanding whatever I'm saying. This is the direction which I wanted to throw. The body wouldn't go like that because gravitational force will pull it down. Change the direction of this velocity and also keep increasing the velocity in the downward direction, which is done by the acceleration to gravity here. Okay. So what would be Vy? That Vy will be 0 plus gt. U is 0. 0 I'm not writing. We get V equals U plus 80. So V will be simply the vector sum of these two velocities. That is V naught square as it is in the beginning. This is extra thing, d square t square under root. And direction of the velocity, if you want to find out, tan theta equals the vertical component by horizontal component. This by this. Vy by Vy. Vx, which is gt by v naught. So after a time t, how much velocity it has got and what direction is it making, all that will be known by this formula. For example, if v0 was 20 meters per second and t equals 2 seconds, after 2 seconds, what happens if you would like to know? It would be what? 20 square plus 10 square, 2 square. This will be how much? 400 plus what? 400 under root. Isn't it? Huh? How much is it? Did I do it properly? 100 into 4, 400. Is it okay? So 400 into 2, which is how much? 20.
20 root.
And tan theta also you could calculate if you wanted. GT 10 into 2 time by V naught 20. 20, yeah? V naught is how much? 20. So what do I get? 1 by 1, 1. That means theta is
45 degrees.
45. After time, 2 seconds. So the first thing is to find out the velocity after some time. I told you already V0 will be known to you, means that's what I mean by giving this V0 is 20. And after time t, how much is the velocity? But remember, this velocity is no more going to be horizontal. It will be like that. But this velocity is horizontal component will be as it is because G is acting down. That's not going to affect this V0. But in fact, because of this G down, though the body did not have a zero initial velocity here, it keeps gaining velocity in vertical direction. So the total velocity will be more than the magnitude of total velocity will be more than what you've given here. V0 was 20, we have seen, but V was 20 root 2 after a time 2 seconds. Hope you all understood. Have you? And remember, this is most important. And this is also the intermediate syllabus for people. Say this question may be there directly, IPE. Whatever discussion is happening is IPE. Of course, we do more than IP. Only 30 to 40% of what I discuss is for IP, and the extra is for our problem solving later. Huh? So can I continue? Takshil, are you writing?
Yes,
Did you
sir.
tell your father to speak to me? So what after this velocity? Next thing, fascist. Next thing is like you did in the previous one. How much distance it traveled in X direction from there, and how much it traveled in Y direction from here. This is our origin of measuring X and Y. 0, 0 there. Here. You would like to know. Look, I can write position. Position, anytime position when you said you're talking of X, Y and Z if it is there at a time t. So this X motion is because of V0, children. The whole idea of two-dimensional motion is, the velocities in the 2 dimensions. You can simply apply the equations of kinematics in individual directions like that. The body is pulled forward and covers some distance X only because of this V0, children. So I can write X equals after a time t V0 into t. No half AT square term here because there's no acceleration in this direction. Do you all follow? And Y equals, there's no velocity in the downward direction. 0 into t plus half G t square. So Y equals half gt square. So X is V0 into t, Y is half gt square. Hello.
Yes.
Nihita, tell me.
Yes, sir.
And all children, I'm telling again and again, first you should become very comfortable, or you should become very familiar. I don't say familiar, highly familiar. There's a minimum thing that should happen. For that, you need to do all this again, all over again. if you really want to improve, attitude is enough. I keep telling, aptitude is all right. If it is there, well and good. If it's not there, no issue. Aptitude, APTI. But attitude can always be developed. Many times, what's happening when I do problems, people are not even they're not able to recall even the formulas, even blindly also. So much time is taken to develop the subject like this. This cannot be, left unutilized, unexploited. What after this, Rashist? From the previous discussion, you can tell the third one will be what? Path. Look into the old one, you will know it. Path is what? Relation between X and Y. So X is there, Y is there. Let me eliminate T from there. Take Y half G. In the place of T, can I write X by V0? So what do I get? Half G X square by V not square. This is like Y equals KX square, no? It's a parabola. Isn't it? The only thing is this kind of a parabola here. Hello.
Yes.
Yes, sir.
This way, this X I'm writing. I'm measuring from here. Do you follow that? Can I continue for the next slide? But you can ask me a question. Suhita. Suhita. Are you there?
Yes, sir.
Yes, sir. Yes, sir.
So I'll continue, children.
Yes, sir.
So this is a parabola equation, but here the apex is here. Previously we were doing like this. Now it is like this. All right. Hello.
Yes, sir.
Yes, sir.
Now, what could be the next one?
Time.
Time. This is H is known. Why am I writing known? Whatever you're calculating in algebraic terms can have H, because H is supposed to be known to you. So in a given problem, H will be given to you. And then it is thrown with V0, we told. And then it follows a parabolic path. We already proved it mathematically. It's falling like this on the ground. The body was here initially. Now the body is here. Okay. How much time? In how much time does it fall to the ground? In how much time does it fall to the ground? Okay. Now H is known, G is there anyway, constant. We can always think that we know it already. So from Y equals, from AC equals UT plus half AT square, I can say H is the displacement. U is 0 plus half. G is also down, H is also down. So both will have same signs. G T square. So if you simplify, 2H by G under root is equal to T. something like this we've seen previously. A body, even if it is dropped freely from here vertically down from a height h, even this will take same time, isn't it? You write h equals half gt square even here. So t equals root of 2h by g. So you need to understand, if I throw one body like this with some horizontal velocity, body A, another body B down like this, if I make them fall, this will go straight like this, and this will go in a parabolic path, but both take the same time.
Excuse me, sir.
Yes.
Sir, here you have written h equal to 0 into t plus half gt square. How is u 0, sir? Because you are adding a certain velocity, right?
What were you doing when I showed this uy is 0? The velocity is only this in this direction, not in this direction.
Oh, okay, sir.
Component of this velocity v0 in this direction is 0. v0 cos 90. If you want
Okay,
mathematical. So there is no velocity in y direction at all. Okay. Tell me.
Yes, sir. Yes, I understood.
That's
sir.
what I mean by understanding, not looking at certain things, some letters I put there and okay, I'll remember it is. No. That's dangerous. You need to ask. Either you should follow, you should have followed it, or you should have asked. So did you follow this one, this particular application which I showed here? Huh?
Yes, sir.
Application of what? This formula. Whether you throw it like this or leave it like this, release it like this, they should come to the ground in the same time. Vishnu?
Yes.
Are you convinced about it?
Yes. Sir.
How do you explain it?
Like if you throw an object parallel to the ground, or if we throw it directly, with both gives the
not throw it directly, leave it.
Leave it directly. Yeah.
Freely drop it.
Freely pot. Yeah. Yeah. Like we can apply initial velocity, no, sir? No.
If you apply initial velocity, it will be different. The time will be different. Huh?
Yes, sir. Like we can apply any kind of velocity to the if we throw it parallelly.
No, whatever velocity given a parallel direction, that's not going to affect the time of fall. That's what the whole idea is. Whether v0, 2v0, 5v0, nothing.
Yes, sir.
The whole idea is that you need to say it is not unusual. It is very obvious, because whether you throw horizontally like this or release it freely like this, in both the cases, initial velocity is 0 only in the y direction. So this should not affect the time it takes the ground. Only thing is A will come here, B will go there. That's what really, that should sink in the mind. Nihita. I'll tell you, anybody here, you talk to me, I'll improve you. But if you don't talk, it goes on like that. The very practical thing, you can check it. Take two heavy marbles like this, drop one like this, throw one like that, simultaneously.
Like if we take a gun and if we shoot the bullet.
Huh?
Like if we take a gun and we shoot a bullet parallel to the ground, and if we throw a ball at the same time when the bullet is shooted,
they should come to the ground at the same time. Only thing is, if you do the experiment very properly, the air resistance will come into picture. But otherwise, for small objects, the air resistance is not so, it doesn't affect things so much. Huh? In practice. Yes, but if you want to do it without air, go to the moon and do it. Do you follow?
Yes, sir.
Moon's G is less, 1/6 of what we have on the ground. It's 9.8 here, it is 9.8 by 6 there, approximately. So there's no air at all, no atmosphere at all. Therefore, you can test it only under gravity. Hello. But
Yes,
I'm not yet clear that all of you got my point here, everybody. Phyllis, have you understood what is told here?
Yes, sir.
Can you just repeat it for me?
Yes, sir.
Tell me.
Sir, when we leave an object freely, sir, both that if we leave any two objects,
I'm not able to hear properly. There are two objects. One freely dropped from a height, the other horizontally projected from the same height. They will come to the ground at the same time. The reason being that in both the cases, the downward velocity is zero only.
Yes, sir.
You understand my point?
Yes, sir.
The time will depend upon g and initial velocity.
Yes,
But
sir.
remember that initial velocity is the velocity in the y direction, in the downward direction. This is not going to affect it. These two motions are independent actually. This is the first contribution by Galileo actually. He understood that yes, when you throw a body, this will remain as it is, but the g will change the velocity in the downward direction. Is his first contribution actually, the independence of these two velocities. Hello.
Yes, sir.
Beautiful problems are framed on this, like one question. There's a monkey here in a tree. One hunter points a gun towards it to shoot it. But monkey is clever monkey. So that will, as soon as it sees the shooter, as soon as a gun bullet leaves the gun, the monkey starts falling. Will the bullet hit the monkey or not? At t equals 0, the bullet is fired like this. Exactly that point, directed exactly towards the monkey. But monkey thought he will escape from the bullet if he just falls down like this. Will he escape? Or if he doesn't escape, why not? Where will the bullet hit the monkey? All that, you tell me. Of course, this is not directly connected with this, but this kind of to understand the motion in 2 dimensions individually. Amar?
Yes,
I want
sir.
to create some interest, so I went for that.
Yes, sir. It didn't escape.
Tell me.
If it is falling, if it want to fall, it didn't escape, sir.
No, I did not get you. My question is whether the bullet will hit the monkey or not.
Sir, when the monkey is there, na sir, or monkey is falling.
Falling. That monkey is clever, no? He sees
Yes,
that
sir.
bullet coming, then suddenly he
Yes,
falls
sir.
down to escape from it.
Then bullet hits, sir.
Hits it.
Yes, sir.
తెలుగులో చెప్పు. అవును, ఇక్కడ ఇది
Yes, sir. Bullet
రిలీజ్ అవ్వగానే అది ఫాల్ అవడం స్టార్ట్ చేస్తుంది. అమర్, bullet will start here.
Yes, sir.
V0, but it also starts falling down like this.
Yes, sir. Bullet కూడా parabolic path చూస్ చేసుకుంటుంది కదా సార్.
అది బుల్లెట్ ఇట్లాగా వెళ్తుంది. సో మంకీ ఇక్కడికి వస్తుంది, అప్పుడు హిట్ చేస్తా అని చెప్పాలి.
Yes, sir.
But you should be able to discuss the physics of it properly. Hello.
Generally,
Yes, sir. So
if we should,
it hits correct. Amar guessed it right, but more explanation is required. Just keep it aside. Now I'll give another question related to this here. All are similar ideas. Now, look, there's a target here. Enemy's truck is stationary, parked here. It's not moving. Parked vehicle. This has to be hit by a bomber fighter. So this pilot sees this target and will release a bomb. Whether it should release here or release the bomb somewhat before he came to this target.
So he should release it before he came to the target.
Before only he should release. The bomb will follow a parabolic path and hit it. That's what we say from here. But the bomber fighter says he's dropping it like this, isn't it? He'll release it somewhat before the target only, before he reached the target's level. But the bomb for us will follow a parabolic path and hit. For him, the path of the bomb will be only vertically falling. No, but now my point is not that answer. How do you explain this? These are very important. Explain from our kinematics there and from the idea of reference frame. Okay, keep those two things in mind. We'll come back to them again. So have you understood that the two times will be same? One dropped with initial velocity 0, the other thrown with any horizontal velocity, doesn't matter. Both will come to the ground at the same time, though they fall at different points. Okay. All right. Next one is what? This range, if you want it. You can call it range or whatever. That R will be because of this horizontal velocity only, children, not because of this vertical velocity downwards. So R should be written as what? V0 into the time it takes to reach the ground. Like in general X, we write as V0 into small t. We have seen it already there. V0 into t. But when t is time of flight or t is total time to hit the ground, X becomes now R, isn't it? This X becomes R. So that R should be V0 into total time. V0 into total time is root of 2h by g. So this fellow, this pilot, the bomber pilot, should release the bomb, which is given by V0 into root of 2h by g, somewhat before this target. In fact, it should become a little horizontal. Even while going in upwards or downwards, you can release the bomb. That calculation will be a little tricky. But if he becomes a little horizontal and then release the bomb ahead of, before the target is reached, that will come like this. How much is that distance? V0 into root of 2h by g. Before that, you leave the bomb there. The bomb will hit the target in a parabolic path as you watch from outside. But the fellow inside, pilot, says only it's falling straight. Okay. Yeah, this here I should have talked about. This is two separate balls anyway. So this range you calculate. And you could also calculate what velocity it will have before hitting the ground. The sixth point in it. The sixth point is the sixth heading is here. Let me draw the picture again. We throw it with V0 like this. This following a parabolic path and falling, we have seen. Like that. Hello. So just here before it falls on the ground, it has a velocity, right? That velocity is once again along the tangent only, children. Any time instantaneous velocity is along the tangent. So how much is this velocity? We would like to.
Yes.
This is supposed to have once
in the
again.
last second it will be in the y direction, na, sir?
Y direction also
Won't
velocity
it
will be there, right?
No, sir. The
No, it won't become y. It will be having two components.
both x and y direction.
Why
Yes,
not?
sir.
Because V0 is not going to change, but the body is going on gaining velocity in downward direction. So both should be there, right?
Yes, sir.
Yes, sir.
This will be nothing but gt, where t is the time to fall to the ground. This is V0. So V equals, tell me, V0 square plus g square t square. That is V0 square plus g square. T square is how much? 2h by g. So V0 square plus 2gh. And Sriram says this we can get from energy conservation also. We will definitely. Sriram. Is not there. Sriram. I don't know.
There's another way we can counter that, right? Because in this case, the y direction will be root 2gh.
Yes, sir, am I audible?
Yeah. Like he says, V equals V0 square plus this velocity will be in terms of height, root of 2gh, because in that direction you can write V square minus 0 square equals 2gh. Right? So V square is straight away 2gh. Okay? Hello.
Yes.
This way, that way, energy way, all are actually same. All the paths, all the religions lead to only one thing. Like that, the concept is same everywhere. But anyway, you need to have looked into all kinds of approaches. Come on. So now immediately after this, there should be a revision kind of a thing. Summarization or list of formulas. So if you finished it, I'll make you list out the formulas for me. So one type of the motion we covered. So first type was this, right? Second type is now this. Hello. First type of projectile, the second type of the projectile. Of course, let me go for one more because anyway time is there. After that, we'll come back for summarization. Can I continue?
Yes.
Takshil, are you writing? Enoch, are you there?
Yes, sir, I am ready.
So
Yes, sir, I'm there, sir.
now look at this. Why should you throw horizontally? You can as well throw somewhat like this. Okay. How will be the path of this Enoch? Even this will be parabola, remember it. But once again,
Yes,
like that we should draw. Don't take it away above that. I told you the trick of it all the time, isn't it? Hello.
yes, sir.
You throw like that.
Yes, sir.
The body will follow path like this. This is given, but the angle also must be given. And anyway, this height is known. Now, many things we can do. In this case, now we should resolve the, say for example, in what time does it hit the ground? What should I do? Resolve the velocity. Huh? What do you say? This is V0 cos theta. And downward direction V0 sin theta. So the times won't be same for a body like this and for a body freely drop. Do you follow? Hello?
Yes, sir.
That was the case only when the velocity is completely, horizontal direction. Now here, for the time sake, because I know h from s equals ut plus half at square, what can I get? S is downwards h plus h. U sin theta is downwards, so plus V0 sin theta into some t plus half g is also down t square. So if you solve for t, you'll get time. Do you understand? Hello? And you
Yes,
should
sir.
be able to write the answer without doing if you remember the old kinematics things I've done. Otherwise, you may try it again. Do you understand why for all of them I've got plus sign there? H is down, V0 sin theta is down, G is down. So all of them have got the same sign. Hello. So 2H is equal to 2V0 sin theta into T plus G T square, isn't it? Hi, children.
Yes.
So GT square plus 2V0 sin theta into T minus 2H is equal to 0. Isn't it? So T will be what? Minus B. Hello.
Minus 2V0 sin theta.
Right. Plus or
Plus
minus B square.
4B squared by theta.
B square minus
Uh,
4AC minus
Yes.
A is this plus by
Yes, sir.
hello. Hello. I cannot hear you. Nihita, are you speaking?
Yes, sir.
Tell me, Amma.
It should be 16 V naught square sine square theta, right? Because it's 2 V naught sine theta.
Ax square plus bx plus c equals 0. If you write x equals, what is the quadratic formula? Tell me, Nihita.
Yes, sir. I understand.
So
I
it is correct.
understand.
This is b. So b square is this only. All right.
Got it, sir.
Right.
Yes, sir.
Minus V0 sin theta by G plus or minus. Now tell me what will come out from here if I want. Hello. Two will come
4.
out.
So 2. Yes.
So what will I get here?
E squared sin square theta plus 2GH.
By 2G. Right. So this minus won't work because the time will be minus. So plus of this and minus of this will work. So the time will be what? Root of V0 square. I could have guessed it. Plus 2GH. Some people have done similar things previously by G minus This has got a meaning if you really try to interpret the result. Okay. Could somebody dare interpret the result? Vasist or Vishnuvardhan, Enoch? Tell me. Ganesh, are you coming to the class? Are you there? Ganesh, Sriram, Shivacharan.
I am this.
So something we did previously, similar to that we've got here. Okay, don't worry, we'll see. But tell me whether you really understood the whole thing. It's not over yet. I just simply found out the time for falling. If you wanted this R also, you could find. R will be what? This component V0 cos theta into this time. That's all. No half AT square term here because there's no acceleration in this direction. Whatever acceleration we have is only in this direction. So the whole idea is to treat the motion in X and Y direction independently of each other. So that is the philosophy behind this whole two-dimensional motion. If you followed it, I'll show a similar thing. I did not do other things like you can calculate. If I wanted velocity here, there is initial velocity in this direction, there is initial velocity in this direction. So you can calculate Vx and Vy and do it. Just for the sake of one more case I've shown, but otherwise there's nothing like derivations and you keep remembering things blindly. So one more I can finish if you permit me to go to the next. Sai Takshil.
Done, sir.
Did you write all this?
Yes, sir.
Takshil, I'll tell you. If I have what you call a very low level target for you, I could do this. Teach only few things, very minimum things, and keep repeating it again and again. And give problems in the same thing or same problems again you give. And show marks is one method teachers and the institutions follow. I'll tell you, that is just the customer comes to you, you should satisfy them. See, come on, what do parents know? Like what kind of teaching is happening and what kind of testing is happening, no one knows. And you spend a lot of money, time, and parents cannot give you time. So, I mean, they have that feeling that I'm not taking care of my child. Okay, because nowadays both the parents will be working generally. So they spend money and join you somewhere. Now, if you don't get marks, so that will be a bad thing for them. So they, once they see the marks, okay, they say, okay, I've spent money, he has got marks, so something is happening. But remember, that will take you nowhere. Serious learning, like which I'm already showing here. How many times I must have done this? Wouldn't I get bored to do the same thing again? But I won't, because I try to elaborate as much as possible to you people so that you catch it. But if there's no feedback mechanism, like if you say you are hurt or not hurt, naturally when I pinch you like this, you'll say no, don't, because you are hurt. So I'm pinching you now, giving those things, all these things, and discussing so much. So you should know, sir, it hurts, it's hurting, tell me what is this happening here. Then you actually get what you want. The lesson is very dynamic, very flexible. From here to I can jump somewhere, I can come back here, I can go somewhere. It's such a beautiful scheme of things in physics you have before. So I want your feedback, not just few boys and 1 or 2 girls, but all of you. Can I go to the next one? I waited.
Yes, sir.
Now another type of a projectile. Third, now we did 3. First one was what? This one, right? Second one was what? This one. Third one is what? This one. Huh? Fourth one could be what? Can you check? Can you guess?
Upwards.
This way. So it will go like this. I'll draw it again. It's not looking nice. Not looking proper. This height, let me put. This is H. Just a reference line you draw. And there's a velocity, children. That velocity now makes an angle theta with the horizontal. So how will be the path of this, children? Once again, don't take it above like that. It should be like this only, right? Hello?
Yes, sir.
Like that. Do you agree?
Yes,
Yes,
sir.
sir.
Once again, H is given to you. V0 is known to you. Theta is given to you. So in how much time does it fall here? In how much time? Does the body fall to the ground? Who will try? Who will try? Ganesh, Sai?
Sir, can I?
Vishnu, come on, no problem.
Yes, sir. The displacement in the y direction is 0. H. H. Yes, sir. Displacement in the y direction.
Is 0.
H.
Yeah, H. Of course. H or minus H, we'll see. For
Yes.
that, first of all, I should resolve the velocity, right? V0.
Velocity. Yes, sir.
Cos theta, this is
Cos
V0.
theta.
Sin theta.
Sin theta.
Now,
Yes, sir.
H is known from S equals ut
ut
plus half
gt
at square.
Yes, sir.
SC is minus H, should I say, or plus H? If I
Yes, sir, we
give
can
plus
take
sign to
minus or
this, I
plus.
should give a minus sign to
Yes,
this,
sir.
correct?
Give minus 10 to this.
Because H
Yes,
is
sir.
downwards like this.
Downwards. Yes, sir.
So
Initial
minus H
velocity is
equals
upwards.
V0
0 sin theta into
into T plus half into minus G T
Yes, sir.
square. Isn't it so?
Yes, sir.
You can
G
solve
is
for T and
downwards.
tell me what you get. It will be similar to this. Probably you might get plus here. Do you understand? Hello.
Yes, sir.
V0 square. What is it? V0 square sine square theta. Huh?
Yes.
V0 square sine square theta plus 2gh by g plus V0 sine theta by g. You might get. Sorry, there's nothing here. Okay. So this is what the time. You can solve and tell me.
Sir,
Yes.
sir, I did not follow the signs, sir.
Why have been telling the same thing all over again and again? No? Sai, tell me, where is the trouble? You want to put, and if you want to put in IJK, automatically that will be taken care, Sai.
Okay, sir.
First of all, do you recognize that for this H we should take this velocity? Not this one. For the vertical displacement, vertical velocity only should be taken. For the horizontal displacement, horizontal velocity should be taken. Is that clear?
Yes, sir. That's
Now, why there's a problem with sign, you tell me.
yeah, got
Vishnu,
it, sir.
Vishnu, talk to Sai Ganesh and tell me. Tell him or somebody else. Vishnu or Enoch. Do mistake there. What is there? See, this is a velocity vector component. This is a displacement vector there. So S equals C plus half d square is displacement equation, right? So the body was here initially. It came down. So displacement is h. That's okay, no issue. But what kind of sign I should give? I should give it in terms of the initial velocity and acceleration. G is down. Even this we took minus. This is down, we took minus. This is up, we took plus. If you want to take this as minus, take it. This will be plus and this will be plus. In the very beginning, Sai, I told you, no? Hello.
Yes, sir.
No. Your own issue there. You tell me, Ganesh.
No, like I got confused.
Okay, right. No problem. Now, just tell me whether you got this one also. This one, I just wrote from there. From here, I wrote.
Before one, yeah. Yes, sir.
Here I wrote plus basically. So because I know there is some connection.
Yes, sir.
So one first type, second type, third type, fourth type is that. Only time I calculated. We can discuss it further. Somebody can say, sir, can I not calculate time from here to here and then from here to here also? You can. Keeping all that in mind only, I wrote it straight away.
Yes.
I'll analyze it a little later, of course, tomorrow. But just do practice. Practice here is doing this one, what is done in the class, again by yourself. By yourself, when I said, what does it mean? It means just look at that, read it once or twice, throw it away, take some rough sheets, and keep doing the things. And whenever you have a doubt, look into that. When you try to do it independently only, you can say that you followed. Do you follow? Say, when you want to give a speech, you'll prepare a speech, for example, at home. And you do the rehearsal, right? But will you mug it up or will you understand and give the speech? And many times people mug it up and they forget there. But those people who understood it only will, because they have to present it in a proper way, they look for proper sentences, words. They don't understand they don't forget the idea. So for example, they got something they missed. So they can talk on their own there. So that thoroughness comes by practice, of course. Not by blind practice, by planned practice and deliberate practice we mean. So are you getting the same thing, children? I'm waiting for your answer before I close.
Yes, sir.
Yes,
sir.
Yes, sir.
So
okay.
you can.
So I hope that you will follow my advice. Do these 4 types once again. All the formulas you rederive on your own. Okay. I'll close it. We'll meet tomorrow again.
Thank you.
Sir.
Thank you, children.
Thank you, sir.
Thanks.
Thank you, sir.